For this demonstration of reinforcement learning, we will solve the problem of the frozen lake. The goal is for the reinforcement learning to find the path for this guy to reach the goal here and avoid the place where you have some a hole on the ice. Okay, so let's see what the code looks like. We have a first part to select which frozen lake puzzle we will solve. The one with 4x4 cells, or the one more complicated with 8x8 cells. So first we will select this one, the 4x4 cells. On this part, we have the definition of all the hyperparameters. So the total number of training episodes, the learning rate. Here we have the gamma for the discount rate. For the epsilon greedy strategy, we have the definition of the max epsilon, the min epsilon, and the decay rate, which is used to decrease the value of epsilon from the maximum at the beginning to the minimum at the end. And now to initialize the game, it's very simple. You just have to define here the ID of the puzzle, this one or the other one, and call a Python module which name is gymnasium, which is imported here. And here you have a very powerful method, make, which initialize all the environment. Then we print some information here that we will see later. We initialize a Q table with a dimension of the number of space and the number of action. Then we use the reinforcement learning algorithm to train and learn to compute the Q value inside this Q table. So let's run the program. Okay. So here we can see that on this program, on this game, we have 4 possible actions: going up, going down, going left, or going right. And we have 16 states, because the guy can be here, here, here. It has 16 possible positions on the frozen lake. So 16 states. And here you can see the evolution of the training. You have for each for some steps, for example, after 17% of the 10,000 training episode, we have a mean reward of about 522, so it's not a lot, over 2,000 episodes. So it means that it succeeds to reach the goal only on 1/4 episode. So it's not a lot. But when the training progress, this ratio increase. So at the end, it succeeds to reach the goal on 1,869 episodes over 2,000 episodes. So this is what this plot reflects. At the beginning, the performance is very poor. Only on 30% it reached to the goal. But after 10,000 episodes, it succeeds to reach the goal on maybe 0.995%, 95% of episodes. Okay, so here is the Q table. So we have 16 rows because we have 16 states, and we have 4 columns because we have 4 possible actions. And here is so for example, if you are on this state here, you will choose this action because it is the one which has the highest Q value. So it corresponds to, here is an example of a movement. Okay, so I start to go on the left, go down, right, return to the left. I don't know why. It's not optimum, but it managed to reach the goal. Okay. Now we will change to get a more challenging game, which is Frozen Lake with 8 cells by 8 cells. So we change here. So now we have 200,000 episodes with the same learning rate. On these steps are the same. So now if we run the program, we can see that we have always 4 possible actions, but 64 possible states because it's 8 by 8 cell. The training is slower, just you can realize, because here we have 200,000 episodes to perform, to calculate. And here you have the average reward over 40,000 episodes. At the beginning we have only 30% of success to reach the goal, but at the end, we have to wait for 200,000 episodes to train to have success about 100%. And if we look at the of one episode, so excuse me, I don't know why we don't have the display. Yes, it's a 8 by 8 puzzle, and you can see movement here to reach the goal. Perfect. So in conclusion, reinforcement learning for this simple puzzle works, but it needs a lot of training because lot of episodes, because we need to solve this on this 8 by 8 episode, 8 by 8 game. We have to perform 200,000 episodes, so it's quite a lot.